Hello everyone. In this question, we are asked to find the integral of tan inverse x upon x dx as x goes from half to 2. Okay, so we are given the integral from half to 2 of tan inverse x upon x dx. Okay, so first of all, it looks like there needs to be some kind of substitution. Okay, so if you look carefully at the limits, half and 2 are reciprocals of each other, right? So it is, in my opinion, the best substitution is going to be something like, say, u is equal to 1 by x. Okay, instead of taking tan inverse x or 1, I'm just taking 1 by x. Okay, so if we take this substitution u equal to 1 by x, from here we get x is equal to 1 by u, so we get dx will be equal to minus 1 upon u square times du, right? And when we put the values of the limits, when x is half, 1 by half will become 2, right? And when x is 2, 1 by 2 will become half. Okay, so this integral, if we substitute x with u, we have tan inverse. Instead of x, we can use 1 by u. Okay, so we have tan inverse 1 by u upon, instead of x, I am writing 1 by u here, times dx is minus 1 by u square times du, right? And this will change. The lower limit becomes 2 and upper limit becomes half. Okay, so this is the first substitution. So now this minus sign, if I take it out, this becomes minus of 2 to half. This u goes to the numerator, this becomes u times tan inverse 1 by u upon, this u square is in the denominator, right? So this becomes u square in the denominator du. Okay, so I can cancel one u here, so this now becomes, again this is a minus sign, so if I change the limit, this minus sign will go away. Okay, so this now becomes from half to 2 tan inverse 1 by u upon u du, right? So here in this integral, this u is a dummy variable, right? So I can substitute with the x also. So the value of the constant will not change with the substitution of this, with the changing of this dummy variable. So this becomes tan inverse 1 by x upon x dx. Now here, since x is from half to 2, right? Since x goes from half to 2, x is positive, right? Therefore x greater than 0. Therefore we have tan inverse 1 by x, this will be equal to cot inverse x, right? So we can use this substitution here also. So we have, this changes to cot inverse x upon x dx as x goes from half to 2. And now again, instead of cot inverse x, we can substitute this with pi by 2 minus tan inverse x, entire thing divided by x, and the limit goes from half to 2. Okay, so now if I just separate this into two integrals, the first one becomes pi by 2x dx minus, this again becomes integral of half to 2 tan inverse x upon x dx. So you see, this was the original integral, right? So this original integral, this is also again in the right hand side. So if I take this to be I, so this becomes again something minus I, right? So we have If this integral goes to the other side, we have I'm taking this to be I here. Okay, I'm taking this entire integral equal to I, say. Okay, so then we have 2I will be equal to half to 2 pi upon 2x dx, right? So if I solve this, pi by 2 is a constant, this goes out and this becomes just dx upon x, right? So this is ln mod x. So this is just ln mod x, and the limit of x goes from 2 to half. So I becomes, this 2 goes to the denominator, this becomes pi upon 4 times ln 2 minus ln half, right? Now ln half is again ln 2 to the power minus 1, right? So if this minus comes to here in front of this second ln, this will become plus. So this becomes pi by 4 ln 2 plus ln 2, right? So we have I equal to pi by 4 times 2 ln 2, right? So this finally comes to pi by 2 times ln 2. Okay, so this is the required answer. So we have integration of tan inverse x upon x dx equal to pi by 2 ln 2, right? This is the required final answer. Okay, so this was not very difficult question, you just need to do the correct substitution. Okay, here I use this substitution to be u equal to 1 by x, so I substituted this and changed the limit, and rest I just did this inverse trigonometric substitution here. In place of tan inverse 1 by x, I used cot inverse x first, and then I replace this again with pi by 2 minus tan inverse x. Okay, so these are the two substitutions that I have used here, and then you get the answer. Okay, so this was not that lengthy. Okay, so this is the required answer. Okay, so thank you for watching.